Hi everyone, this is another episode of Live Contract Reviews, and today we have another part of the Berry Club series, and today we're gonna review BananaSwap. So BananaSwap was created by Vlad, and it actually written in AssemblyScript, which is interesting because entire Berry Club contract suite is written in Rust, and this one is AssemblyScript, so there's some magic that happens because we use JSON, but it makes it easier to interact between two different languages. So BananaSwap is a website and a contract. It acts like a Uniswap. You have your balances and you have a pool balances, except for Uniswap contracts, you can deposit extra liquidity. And for this implementation, the liquidity cannot be added, so it only mined by the contract provider. So Vlad, in this case, mines all liquidity and all the commission, but the amount in the pool grows because the commission is about 10% for every swap. So the interesting part about this is, like, you say, I want to convert near to bananas. So let's say I want to get 10 bananas, then it does a view call to the contract and computes how many bananas is there, how much near I need to spend to get 10 bananas. So I started playing with this yesterday to see if I can some kind of abuse this implementation. And one idea was, like, can I bring this number to overflow? So I started playing. It's like, hey, I want to buy like 700 bananas. Like, okay, the amount of near is this. Can I buy so much bananas? And it's like, okay, we get not enough berries in the pool. Like, what? It's saying you have enough berries. Like, what's going on? So I don't know why that started to happen. So I started to play this around, and like, still not enough, but 20 is for some reason is enough. So either this balance is invalid that was displayed here, or there's some mass happens that makes this issue, but you can like start playing and like finding this weird number until you're like exceeding this number start growing, and this is because how Uniswap works. When you're trying to withdraw almost entire liquidity, your product stays large in the past, but the denominator actually decreases to like minimum, which is 1. So your number of near that you need to pay will be the product of bananas by near in the pool divided by 1, if I can find the correct number here. So I wondered if Vlad put a protection on the overflow and started exploring the contract yesterday to see if I can trigger an overflow, such as I don't have to pay so much near, but can take all the bananas. And we'll see if it's possible once we start reviewing the contract. So the contract is written in AssemblyScript, which is similar to TypeScript, and it's just one file. So it starts with a bunch of constants. So this is amount of near, and because AssemblyScript had weird big number implementation, this contract uses U128. and it uses a trick where it divides large number by mean fraction, which is 10 in the power of 12, and then it does the product, and at the end it multiplies it back. So it uses minimum balance of 5 near, because the contract only compiled binary out of this contract is only something like 20 kilobytes. So you only need about like 2 near for the contract binary and a few more near for storage. Well, storage is constant, so it's not an issue. Now, the way it works, there's two methods, start and stop. The owner can start a contract and the owner can stop the contract in case something goes wrong. The owner is checked if it's called by itself. So I assume Vlad has the keys to this contract, so he can stop it if needed. It initializes the amount of berries the contract has and sets this as an initial liquidity. So maybe pool, the number in the pool that displayed here is actually fetched from a Berry Club contract, not from BananaSwap contract. So not an inner balance, but actual balance that is the contract owns from the token contract. That's why it might be a discrepancy. So there's a few methods. So one of them is like a view method to get a buy price. It passes, you say how many berries you want to buy, and it gives you how much in near you need to pay using get price internal. And then you have buy method that buys bananas. Then you have get sell price, and you have a sell method that is internal because you can only trigger it from calling transfer with vault from banana contract, from Berry Club contract. So at the end we have implementation for transfer with vault receiver. So on receive with vault, which is the interface that banana contract communicates, or like Berry Club contract communicates with this BananaSwap contract. And it verifies that it can only be called by the token contract. And it has two methods, sell and deposit. Deposit cannot be used if the pool is already started. So it only left with sell. And sell, it means you trying to sell some number of bananas for near. So let's start with method buy. And or we can see how the buy price is calculated, because it's called get price internal. So buy internal is, it takes the amount of berries it has locally remembered from the storage, divides it by this 10 in 12. So bananas, precision of banana token is 10 in power of 18. So this one is 10 in power of 12. So it brings it in order of a million per one banana token. So if it has around 1700, or more realistically this number, then this will bring it to something like 1.7 billion So internal berries becomes 1.7 billion. Berries is how many berries you want to pay. It's also like adjusted to the same denomination. Then it does two checks. One, it verifies that the amount of berries you passed is positive. So you cannot buy 0 berries. And then it checks that you don't want to buy more than the amount in a pool or the same amount. So you cannot drain full liquidity from the pool. Finally, it calculates how many berries remain in the pool. It calculates the near amount without the storage required balance. So it uses actual amount of near in the pool on this account. So it's not remembered amount, which is important. It means this variable can be modified outside of this contract. So if I deposit 5 near to this contract, then this value will grow by 5 near. So it also divided by 10 and 12 in power of 12. Near is denominated in yocta, which makes near to be 10 in the power of 24. So per near, you need to multiply it by the 10 and 12. So we have, this is 1.7 billion. This becomes 8.7 trillion. Now, it does a Uniswap trick where the product, which is current berries by current near amount, is constant. So we divide by a resulting berries. So this is how many near, the new near balance of the pool has to be to maintain the invariant where the product is constant. Then we calculate how many near you need to attach. Because this number is positive and this number will be higher because this number is less than internal berries. So this one is also positive. So it calculates how much in near you need to attach, and then it multiplies it by mean fraction, which is another power of 10 and 12. And it calculates this commission. So it calculates commission. The way it calculates commission is it multiplies by 110% divided by 100. So this is the overflow I tried to abuse. And the overflow here in AssemblyScript just does a rolling overflow is if I can bring a price to a level of U128, where by multiplying by 110, I will be able to overflow it to a very low number, then my final price will be low. So we'll come back to this. So that's how you calculate the price. Then you say, hey, did you attach enough near to cover this price? If not, well, sorry. Then we just update that we decrease the internal near berries balance, and then we send the remaining deposit back. So there's no overflow because it's checked here. And we do a transfer row. So we basically just give the predecessor berries directly from the contract, token contract. And that's it. This is the buying method. Any questions on this part?
Maybe like an overall question. So who is putting in the berries? Are people putting in liquidity, or does the contract itself have the berries?
Yeah, so there was no liquidity initially. Well, like there was very low liquidity initially, but because Vlad put some near originally, and because of one commission of like 10%, overall liquidity grow because of the commission and the pool and like near that was deposited there.
So it's 10% of berries.
10% of the price you need to pay. On every
Okay.
swap, you pay 10% in commission. So it's kind of slippage of 10% extra. Cool. Now the sell price works fairly similarly. You say how much near you want to get, then it calculates current near amount, it calculates berries, calculates your near, it has to be positive, but not full pool. Then it calculates how many new near balance. So what should be the new berries balance? Then it divides new berries by old berries, or like subtracts and does the commission. Very similarly to buy. The sell order works from the receiving vault. So when you send some near, or when you send some bananas using vault and say how many near tokens you need using an argument, it calculates, so it calls sell, and then it returns a price that you need to pay. If you paid more than this price, then you'll get refunded. So this is not needed because Vault will automatically refund you tokens. This is an overkill. While then it returns a promise saying, okay, give me the berries that needed. We are done with the transaction. It's maybe possible to somehow trigger front running there, but I don't think it's a reasonable way because while this is not completed, internal berries balance is already updated. So if you try to transfer these berries, maybe you can arrive first, but unlikely. So it calls sell. The sell does the following. It's saying sender berries near amount. So it computes the berry price, how much berries you need to pay. If you attached less berries, then it will fail. Otherwise, it's saying I received so many berries, and here's the near amount that you got, that you asked for. And how runtime works, all promises that you created will be rolled back if later, for example, you trigger an assert. So it's safe to, like, for example, transfer near before some other assert might trigger. But this not happen. So so that's pretty much it. This is the contract, and that's it. So very simple. The logic is fairly simple. The only problem is potential overflow that we can try to abuse. Well, like, I'm probably not going to do this on mainnet because it's still fairly large amount of near that needed to be attached. But let's see how actually it can be done. So let me present a terminal to see where we. 1 second.
While you're doing that, it's crazy that this is like 152 lines of code. This whole contract is awesome.
Okay. All right. So what I have here is, so this tab is on the mainnet, and I can say I want to know the buy price to buy that many berries, by like how much it's near to buy so many berries. So let's say I don't remember where we stopped. I think it was like 7 to 17. So if I will try to adjust this number to something like close but not overflowing, then I'll be able to bring this number to the number of the denominator on the new balance to 1, and that will allow me to get the maximum product. So for this, I need to know the state. So because AssemblyScript how I actually view state? Is there near view account state and
Josh, you know this one? Viewing state on
maybe it's
AssemblyScript
not
with near CLI.
View state.
view state. Is there a view state?
No, there's an
There's
RPC
no near
call.
CLI way to do that. There's an RPC
Yeah.
call and there's some account utils that are in the near examples. Those are the two.
All right. Okay, so I guess we'll have to somewhat just like quickly brute force it. We can write a binary search to actually find this number so it doesn't overflow. So what I'm doing is kind of incrementing one of the digits until I can find a number that's not gonna overflow. And I'll have to continue doing this until we arrive to a number or this 0 digit. So, okay, so we're getting close. So basically, once we're done with this process, or this process can be completed by just querying the state and finding the exact number, then doing -1 from it.
I just sent you the number over Slack.
Okay. Anyway, so this is the number, and it will not be affected by the next digit, I assume, because this digit is already in 10 and 12. Cool. Yeah. So this is exactly what I get using this number. Thanks. So as Sharif pointed out, here's the number that is in the state. So this is what I found here by doing the kind of brute force search. And it's just this digit -1. So this is a remainder that is truncated. So this is the number that we get, which is the maximum price with the commission. So what we can do next is we can divide it by 100, multiply it by 100 and divide it by 110. So this is the product that is currently in the pool. So what we're interested in is the following. What will be 2 in 128 divided by this? 1 second. Right. So this is the number, the 2200 is the multiplier of this number that you need to exceed. Like once the pool product becomes, like if you increase the pool product by 2200 times, then we will overflow to in 128. But as you remember, the code in this commission is actually multiplied by 110. So the actual number we need to increase is only 20. So if the inner product of the pool would become 20.5 times higher, then we will trigger an overflow in the contract. So this code is here, price by 100 by commission percent divided by 100, right? So what I'm trying to do is I have this price, which is this number. I need it to be, to be such that 100 by plus the commission, so like 110 multiplication will overflow it and bring it as close to 0 as possible. So when I divide it by 100 here, the number will be like as low as possible. So I don't have to pay near at all. So I modified Vlad's contract. I added this view method, test overflow, that just simplifies it. It calls view commission and the number I pass is A, and then I have multiplied by min fraction because I cannot avoid doing this. So, and it will call this commission and return it. I deployed it on a test net, and I have this method that I started to trying to figure out the number, the product number that I need to pass, such as that the overflow value will be as low as possible. So I started doing this, but haven't finished. Again, we can do this using using the binary search. We basically can say like, well, if I add a digit here, how the number gonna change? And as you can see, some digits do not change anything because overflow by 110 doesn't modify it. But if I modify this digit, well, nothing happens as well. So, so some digits become significant. So for example, increasing this digit actually did make a difference. So maybe I can decrease it. And so this did not affect. So if I decrease too much, I will not trigger an overflow, or I will mess with So basically what happened is I tried to find the minimum number that I need to pass, such as it will trigger an overflow and decrease the number. So for example, let's look at this number that we have. Oops, not this one. Divided by 10 and 12. So this is the number that is currently passed here by default. So this is the one that I receive on the mainnet. So what I need is by how much I need to multiply this number, which is around this number, such as my product will grow and then it will trigger an overflow. So if I, for example, do this, multiply by this, it just Python makes it a little more complicated. So I can get this number. Then if I pass it, I get the minimum number possible. So this is the price that will be returned if a product can reach this amount. Why I'm doing all of this? So let's go and look at the contract itself. So, and we have operation which is get buy price internal or get sell price. So if I can send near to the contract some amount of near that I know I need to send, and this current near amount will be increased by the amount that I know, then this product will be computed and this commission will be called on the new near price. So basically, I can control near price by providing enough near to the contract itself. So I can send a simple transfer and chain to increase the inner balance of the BananaSwap account, which will result in increasing this product of internal berries by the current amount, where resulting berries is 1, which will eventually trigger this commission to overflow and say to take all berries, you need to pay only one, it's like small amount of near. The problem is I don't really need bananas, so I go to get sell price and I say I wanna all near. So then near amount becomes, so new near balance became 1, new berries becomes very large product, then berry price is computed, and this commission is called for the number that I want, which will overflow again. And it's saying to get all the near, you only need to pay like a few berries, which is like a few bananas. So in our case, it's going to be this amount of bananas, which if you divide by 10 in 18, you basically need 200 bananas to get all the near, but obviously the math may be slightly broken. But here's the idea. So in order to make this kind of overflow hack, what you need to do, you need to deposit precise amount of near to the contract through a simple transfer. This will not modify the inner balance of berries. Then you can send a purchase order to buy to sell bananas, essentially to buy all the near. So like take all the near except for one, and then it will trigger the uint 128 overflow, and you will have to pay only like a minimum amount of bananas to take all the near. And this is that essentially will allow you to capture the like 87 near that is currently in the pool. So very fun hack. At the same time, it's kind of expensive because to get this 20x multiplier at 87 near, you need to like I guess 19.4. So you need to send like 16 or 1700 near to the contract, which is if your math is anywhere wrong, then you may lose this 1700 near. But if your math is correct, you can claim 87 near from the contract. Plus, if someone like front runs you a little bit, just like increasing the balance of bananas, which will break the overflow logic, then you might like just lose or like get your near locked on the BananaSwap, which will make banana price explode. So you can sell bananas to claim majority of near. Here's
Nice
everything I have for today. And I think that's kind of cool that we discovered this type of vulnerability, exploit. And the way to patch it is actually would be introduce just overflow protection. So you can do an extra check here where, let's say, well, if AssemblyScript would support panic on overflow like Rust does, then you can just enable it. But if it's not, then you need some kind of check either here or even earlier. You can like do division to see if this number is like relatively low to make sure this product doesn't overflow. But it's still kind of hard to overflow this product because the amount of bananas in here has to be fairly large. It's still very close, so you want to protect not only this, but also so you don't exceed the product. Maybe decreasing the mean fraction or like increasing the mean fraction even more. That will protect you from this overflow.
So I have a question if I can. This is really interesting. Yeah. So this is like an overflow that happens from some math in here. And on Rust, it's like there's a cargo.toml file, which is very similar to like a package.json. And there's something called like overflow-checks equals true. And that's just like, it seems too good to be true. It's just like, okay, cool. That just takes care of overflows. Does that like, if this were in Rust, would that also account for overflows in like this situation where it's like custom math inside your contract? Would it catch that kind of thing too?
Yeah. Yeah. So the check overflow, it basically makes Rust act like a debug. So on debug, Rust is actually overflowing. Like any overflow in debug will result in panic. So you cannot have a rolling overflow if you don't want it. So they have special methods like checked add, saturating add, like saturating mul, and then they have overflow and mul, which gives you a result, but also whether it was overflowing or not as a second boolean. So you can check if it was overflowing. And like some contracts use it for optimization, so they actually like to overflow and then use this bit to pass, for example, one to the next element in the number on the next bit, like higher bit, higher byte. Yeah, but in order to like abuse this, you probably want to modify this contract, build some kind of like extra logic that simulates what you're doing, and then make sure you execute it in proper order in one block, so no one is like in the middle of you.
I would guess that like, so at the very top, he's like import a bunch of things from near SDK AS, and one of them is U128. I would assume that U128 has like something like max value or something like that
Yeah.
you could use to check against.
Yeah, maybe it even has the overflowing check that you can do. So yeah, but the proper way is just implement U256, which will take care of all of these problems, because you can drop this min fraction, and because near never exceeds U128 and other does not exceed it either, and they're not even close, and you will never reach the overflow here. At the same time, you can first divide by 100 and then multiply by commission. That will also get rid of overflow here, because of min fraction, it's divisible by 100, so you don't lose precision. There are multiple ways of addressing it on this contract.
So, and actually, maybe that's another question for everyone. Is like, it's like January 2021. Is there any reason why we don't have U256 on AssemblyScript and Rust? Was that a choice, or just kind of like we have not just happened to get to it yet?
I think it had some bug in the mass that needed to be addressed, so people don't use it until new AssemblyScript is published or something like this. But there's some big num, I think, module that supports this type of stuff, so like U256 and higher.
Cool.
Any questions, or we can close early today?
Did you steal Vlad's near?
No, I need to like do the math and then need to figure out where I can get this 1700 loan, flash loan.
Maybe he can pay you a bounty.
Just a naive. Yeah, I'll give you some near to give me my near back. Just some naive question. So like, how much of an advantage do you have because you've got access to the source code? Like if you didn't have access to the source code, would it have taken you a little bit of extra time or prohibitively more time?
If there's no access to
the contract,
source code, then it will be much harder to like read the WebAssembly and figure out like what's going on.
So developers are really stuck with this double-edged sword where they want to release the contract code so people can audit it and read it and kind of feel confident that they're using something that isn't cheating them out of the whatever transactions they're engaging in. But it also gives attackers this kind of red carpet access to potential bugs.
Well, at the same time, like you can do the audit and like for example, I didn't abuse this because it was still requiring me an extra deposit, which we don't have access to flash loans on near on a protocol level, so you cannot really execute this attack without funds. But if someone would actually try to figure it out, they will come up with a few options and be able to actually find the number they need to send in near, so they can try send it small amount, see if it increased the product. If it does, then okay, let's try to figure out when it's gonna potentially overflow. So, but they will probably not be certain that this number will overflow and not panic. So they will not execute the attack unless they just grab the binary, deploy it on a testnet, fund it enough, and then complete the attack anyway.
But you initially found this by playing with the front end, right? So it wasn't like you looked at the code first. So that is kind of like, like someone would have a hint, like, hey, there's something here.
Yeah, it gives you a hint, but it doesn't give you a certainty that the attack would be successful. So right now I proved that the attack was successful because I took the binary, introduced this helper method that let me play with it. If I didn't have access to source code, I could still introduce this test method by sticking it in WebAssembly or by swapping the original banana balance to my own contract, which I can control, or deploy it locally and fund in it. So there's multiple ways to execute the same attack without having to do this on a mainnet. So you pretty much can replicate the state of the contract on your local network and then grab the same binary and replace the bananas, berry club contract with some generic token which you can mint and destroy. And after this, you can execute the attack. And I assume Ethereum does all the financial hacks on Ethereum are done fairly in similar way. Even if they don't have a source code, they found some bug. They have a local kind of snapshot of the mainnet. They can execute some transaction, verify it will do what they need, which is slightly easier because you can actually do this off-chain because of synchronous state. So you can execute kind of view call, which does a bunch of function calls. On near, we don't really have this capability where you can take a snapshot and then do a multi-shard or multi-account transaction that is non-modifiable, so as a view, which is requested feature. So it would be cool to have it somewhere, because you can potentially do this on a node that tracks all shards. So you can just do the instant view call on multiple accounts and keep track only in temporary view.
And you could do this in the EVM.
And on EVM, yes.
I feel like I missed something pretty important. I'm having a disconnect with, we trigger the overflow and now I have access to that account, or now I can drain the funds. I'm missing that step. Yeah.
All right. So the attack here, the exploit here is we can do a transfer of near to this account to trigger the overflow. Once you trigger the overflow, it basically decreases the price from this enormous number. So from if I do this, right? So from the price of ridiculous number to something that is overflow to very low number. So now I can drain entire balance back without paying for the for this. So I can basically now drain my funds and the pool funds without paying in bananas for this. So this is data.
So if
You
the
first,
pot of money is big enough, right? Like if there are 1 million near in there, and you can transfer 1,500 near in order to make the price overflow like this, you can walk away with 1 million near. You can net yourself
Well,
1 million near.
even right now, like it just, so your risk is very minimum. It's about your setup, like the preparation that you do. Then you can execute this attack right now and like take about like 82 near from this account by draining the all liquid near balance and pay something like 200 bananas.
Okay.
So you can
cool.
first, for example, acquire bananas, this required amount of bananas by paying near to the pool, which you already want to do, and then you can execute this attack. So you first can take all the bananas out of the pool by paying ton of near, and then you transfer the remaining near, and you now can drain all the near out of the pool. So you basically first took all the bananas and then you took all the near. So pool going to be very low on liquidity after you complete the exploit. Make
Gotcha.
sense?
Thank you. Yep. Thank you.
Okay, I guess we can close for today. Thanks for watching and listening and attending. Have a good day.
Thanks, y'all.